Okay, so lesson today is on page 18. We're going to do 6 examples together, page 18 and 19. So operations with powers. So in elementary school, you guys did Bedmas. Okay, what does Bedmas stand for again? Charles?
Brackets, exponents, division, multiplication, addition, subtraction.
Perfect. Okay, so remember Bedmas, you can also call it BAMDAS because division, multiplication can interchange, addition, subtraction can also interchange. Okay, so right here, I see some brackets. So let's clean it up first. Let's do that. So negative 2 to the power of 4 plus negative 1 minus 1. That gives you negative 2. Make sure if it's in bracket, you keep the bracket because otherwise you're going to lose the negative sign somewhere. Okay, and then everything else, I'm just going to copy it straight down because I haven't done anything with it. Okay, I can't do anything more. Okay, so I did brackets. Now exponents. Okay, this negative 2 to the power of 4, what does this equal? Who could tell me what this equal? Negative 2 to the power of 4. Yep.
Negative 16.
Negative 16. Good job. Negative 2 to the power of 4 means negative 2 times 2 times 2 times 2. All right. It's only one negative and you're only multiplying the 2 4 times. Okay. So that's why this gives you negative 16. Charles?
Well, it's just if the exponent is 2, then it's even.
Oh, good point. It depends. This is an even exponent. So a lot of people are thinking, why isn't it positive? Because there's no brackets. Okay? When there's no brackets, there's just one negative sign. Right? If there were a bracket, then it would have been negative 2 times negative 2 times negative 2 times negative 2. Okay, so you see the difference? Okay, so just like this. This will mean negative 2 times negative 2 times negative 2, which gives you negative 8. All right. And then same thing right here. Here, I'll write this out here, up here. So this one, there is a bracket. So then this will mean negative 2 times negative 2 times negative 2 times negative 2, which gives you, yep, negative or positive? Positive, because there's 4 negatives in total. Yeah. So you see the difference between the two? One gives you a positive 16 and one gives you negative 16 as your answer. So be very careful with this. You will see this on the test every year. We put that question on, all right, to test to see if you guys know the exponent rules and with the negative signs. Okay, so that's exponents. Next, division. We don't have division, so multiplication. Okay, so negative 16. This I can simplify. Plus minus 8 is just minus 8. And then here, 5 times 5 times 16. When you have a number side by side, it does mean multiplication. So 5 times 16 is 80. Right? And then lastly, adding and subtracting. So on your calculator, negative 16 plus minus 8 plus 80, you get 56. Okay. Now, a question like this on the test, it may be like 3 marks. Right? I wrote 4 steps right here. So I don't need all 4 steps, but if you see that the question is out of 3, then you want to show at least 3 steps. Okay. Are you allowed calculators on the test? Yes, every single test you are allowed calculators, even for this number sets. So what I could do is after I show my 3 steps, I can actually use my calculator to check my answer to see if I got it correct. So I'm going to go back to my original question, -2 to the exponent 4 plus bracket -1 minus 1 close the bracket to the exponent 3 plus 5 times -2 in brackets to the exponent 4. Okay, if I did all my math correctly and I punched in the number correctly, I should get the same answer. Right, so if I don't, double check your work. Okay, so you should be getting close to perfect on the test. Okay, let's try example 2. Oh, question. Oh, yeah. So since this bottom axis is -3 times negative times 3 times 3 times 3 times 3, which would be -81. Okay. Plus bracket of 62. Okay, so I can see that Sam is skipping a few steps. That's good. Again, just make sure if it's out of 3, you show me at least 3 steps. If it's out of 2, then show me 2 steps. So right here, instead of going to brackets first, he did the exponent right here because it didn't affect anything. It doesn't matter if you want to just rewrite it first or simplify it first. Both are fine. So in this bracket, -2 minus, I'm just going to show the steps here, how he got that 62. -4 times -4 times -4, -64. These are just square brackets right here. Okay, and then I'm going to keep that root 16. So -81 plus, if you take a look at this right here, that's why I want to keep my brackets. Especially when it's negative, you want to make sure you keep that bracket. You can see -2, this becomes plus. So -2 plus 64 gives you the 62, as Sam said. Okay, and then what is square root 16? It's just 4. Now, just a quick little extension right here. Square root, where does it go in Bedmas?
Exponent.
Okay, Charles? What is the exponent for square root?
Um, divide by. Square root is like when you try to get like 4 times.
Yeah, so it is exponent, but what is that exponent for square root? Ahira?
It's like 2 squared, like squared numbers.
Okay, so.
Like, for example, like square root of 16 is like 4 squared.
Okay, yeah. But there's actually an exponent for just the square root. Not division.
It's like 1 divided by the square.
Right. So
exponent, sorry.
square root 16 is actually 16 to the exponent a half. All right. You don't need to know this for grade 9. This is just a little extension for those who are interested. You'll learn more of this in grade 10 and 11. Okay. Especially in grade 11. Okay. So square root is actually exponent a half. And then cube root will be exponent 1/3. Okay. So just thought I throw that in there. Okay, and then so now this is just regular plus and minus. So -81 plus 62 plus 4 gives you the final answer, -15. Is it -15?
Yeah.
Okay. Okay. Any questions so far? Okay, example 3. Evaluate this when x is -4 and y is 2. So throwing in a little variable in here. Right? So this is basic variable. So all that means is I'm going to replace the x with a -4 and replace the y with a 2. So this is what I'm going to do. Okay, I'm replacing the x with a -4 and replacing the y with a 2. Okay, does this look correct?
Yeah.
Did I do so? I think Sirius thinks no. Right? did I substitute this in correctly?
Yeah.
Okay, so who says yes? I did it correct. Okay, who says no? Miss Ching is wrong. Okay, yes, I'm wrong. What did I do wrong? Okay, Sydney.
Um,
Yeah.
there's like brackets.
There is brackets. That's right. Whenever you substitute, you have to put brackets around that number. Because otherwise, I just changed the question to 3 minus 4, which is not what I want. So I have to put brackets around the number and just the number itself, like this. So whenever you substitute, you must put brackets. Okay, otherwise you're gonna change the question and lose your negatives. Okay, so right here, oh, and this is also another common mistake people do. Should I multiply the 3 first or do the exponent first? Exponent. All right, so I saw it on the final exam. So many people did -12 and then did the exponent. So remember Bedmas. You guys were practicing all this Bedmas since grade 6. So -4 times -4 times -4 gives you -64. So 3 times -64 plus 16 over -8. Okay. And then when you multiply it, -64 times 3, -192. Okay. So Bedmas says I should divide before I add. Should I divide this?
No.
No, because there's like you always have to clean up your numerator and denominator first before you divide, just like if there's an invisible bracket around it. So you actually have to clear this first. So -192 plus 16, which gives you -176. So when you now divide it by -8, is my answer positive or negative? Positive, because 2 negative make a positive. So my final answer, 22. Okay. Okay, make sure you're copying this down, part of the notes. Okay, any questions on this Bedmas stuff? Okay, I know you guys have been doing Bedmas since grade 6. So this is kind of like a recap as well. Charles.
Was the bracket around the -2 necessary? As you said, like if you're using a bracket and you put an exponent on a negative number, it will turn out negative.
Good.
In this case.
Yeah, good point. So in this case, it didn't matter because it was going to be -8 anyway. But for formatting, you should always put brackets around what you're substituting. Okay? Especially later on, we might do like polynomials. We might have to substitute into polynomials. Then brackets is really important. So this is good habit to always put brackets around what you substitute. All right. Okay, so let's move on to page 19. Page 19 is dealing with rational numbers. Okay. So rename the following rational numbers as quotient of integers. Quotient of integers. What am I talking about? Nicklin. Yeah, that's it. Good job. Okay, so basically the question is just saying, can you rewrite this as a fraction? Okay, so why is Miss Chang being so difficult and say like quotient of integers? That's because EQAO use these words. Alright, so they like to make you get the question wrong with their wordings. So if you see these words on EQAO or in some textbooks, just know that all it means is write it as a fraction. Okay, so let's start off with an easy one. Negative 0.25. Okay, what is that as a fraction? Yeah, but how did you get that so quickly? Like if I were to write it out, this would be negative 25 over what? 100. Good. I know to put it over a 100 because I have two decimal places. So two decimal places after that decimal means two zeros. Okay. So then I can tell I can reduce this fraction. So I can reduce both by 25. So therefore I get negative 1/4. Okay. So what about B? 4.225. So I can write that 4 whole first. Sam?
2.25 over 100.
Okay. Okay, but we don't like putting decimals and fractions together. They hate each other. So Sydney, what would you put this over instead? 1,000. That's right. So three decimal places, 3 zeros. Okay, so that's how you know what you should always put it over. But is this my final answer? No, I can reduce this. Yes, like most of the time you can reduce the fraction. What goes into both 225 and 1,000? Pirish? 25. Yeah. So 225 divided by 25, I get 9. And then 1,000 divided by 25, I get 40. Okay, there you go. Okay, who wants to try this one? Okay, Priyash? Excellent. And then I can reduce this down to? Perfect. Good job. Nice and easy. Okay, because I can reduce this. Notice when I reduce, I never reduce the whole number. It's like if I have 4 pizza, I still have 4 pizza, even if I reduce the um, the fifth pizza. Alright, so when you reduce, make sure you don't reduce the whole. Alright, so nice and easy. I think you guys did really good with example 4. Let's move on to example 5, inequalities. So I think yesterday or the day before, we talked about greater than, less than, or equal to. Okay, so do you think fractions are easier or decimals? Decimals, definitely, by far. So easiest way to do these questions, change it to a decimal. Okay, so 2 and 4/5, I know it's going to be 2 point something. What is that? 2 point, Charles? 8. That's right. 4 over 5 means the same thing as 4 divided by 5. Alright, and you'll get that 0.8. So therefore, this is 2.8. Remember your whole is still the whole. So you still have that 2 whole. And then this tells you the decimal part. Right? So therefore, it's less than. Okay. Take 30 seconds think about this one. Think about this one. This is a tricky one. This is a tricky one. Oh, okay. I like the confidence over there. Okay. Uh, I love the discussion over there. Good. Okay, so who says it's greater than symbol? Okay. Who says it's the less than symbol? Okay. Who says it's the equal symbol? Okay, good. I got all three. I love the participation. Okay, so those of you who didn't put up your hand, next time I want to see your hand up. So this one, let's change it to a decimal first. As we said, decimals are so much easier. So -2, 4 divided by 10 is 0.4. So this is -2.4. What about this right here? What is this as a decimal? Nicolin? Because I saw your hand up earlier. So right, this has a repeating 4. So are they the same? No, so they're not equal. Now it's a matter of are they which one is greater, which one is less? Well, let's say 0 is here, -2.4 is over here, and -2.444 is actually here because it's negative, as we said. So -2.4 is actually closer to 0, which means it's greater than. All right, so those of you who said greater than, good job. Yay. That was strange. Okay. Okay. Last example. Okay, last example. Name 3 fractions between 5/7 and 6/7. Okay. If you're thinking 5.5 over 7, nah, because we just said decimals and fractions, they hate each other. They don't mix. Right? So if you write 5.5 or 5.1, that's no good. Okay, Sam has an idea.
Since the number 5 and 6 are right after each other and we can't use decimals, we would multiply the denominator and the numerator by 2.
Oh, okay, so he's gonna multiply each of these by something bigger to make it a bigger gap.
One of them would be 10 over 14, the other one would be 6 over 14. Not 6 over 14, and then the number in the middle would be 11 over 14.
Okay, so I love the idea, but I don't like that you just times it by 2, because when you times it by 2, it's actually not big enough.
Multiply it by 4, because if you multiply it by 3, you only get 2 answers.
Yeah.
You could do 11 over 14 and then 16 over 21 and 17 over.
Okay. Yep. So that's good. So Sam says multiply everything by 2. Sydney says multiply everything by 4. Uh, Liana, did you have a better number to multiply by? Yeah, I would actually even go by multiplying by 10. All right. Give yourself a lot of room. All right. When you multiply the top and bottom by 10, you get 50 over 70 and 60 over 70. So now you have like 9 numbers to choose from. All right. Why restrict yourself? If you're going to multiply something by something anyway, multiply something by bigger. So, if you read the question carefully, I need 3 fractions. Okay. So, what would be your choice, Nicolette? Okay, but I want fractions. I want to keep it as 3 fractions. So 3 fractions between 50 and 60. Okay, Alisa?
53 over 17, 59 over 70,
and 50. Okay, so she said 53 over 70, 54 over 70, and 59 over 70. Okay, so if this was her final answer, she would have got 2.5 out of 3 on this question. Real. Yeah, what can you simplify this to? Yeah, so that is the lowest term. Yeah, so lost half a mark there because it's not reduced. So if you are gonna choose these numbers, you have to make sure you reduce because it's a final answer. Another way to go around it is choose prime numbers. So if you chose 51 over 70 or 57 over 70, then you won't run into that problem. All right. But I love that you guys got this idea. So this is great. So no decimals. You guys expanded it, and then gave me 3 fractions. All right. So that's the lesson. Took 26 minutes, a little longer than usual, but still, you still have a good 40 minutes to do your homework tonight. Your homework tonight is page 20 and page 21. So these 2 pages. Answers are on the bottom for you to check your answer. Check your answer, not copy. Okay. And then look what's on page 22. What's on page 22? What's on page 22?
First page.
Yeah. The review. So it means we're finished chapter 1. Yeah, we're done chapter 1. Tomorrow we do the review. All right. And then on Monday we take up the review. And then how many of you feel that chapter 1 was easy? All right. How many of you think you can ace the test next week? Okay, I saw some hands up. Not everyone. When is the test? You guys are the other class. So you guys are. Whoops, sorry. This one. So your chapter 1 test is on Tuesday. Tuesday. Everything in this package with the review. It's written on Brightspace, and these are the topics. Okay.